Good afternoon or good morning, everyone. We are very pleased to welcome all of you for joining us for this webinar today on decarbonizing building construction in India. I am Shravani Kilwar, a research associate in the Industrial Energy Efficiency Vertical at IEEE, and I will be moderating the session today. I am delighted that we are having this webinar, as I believe this is an important topic for us to be talking about. We all know that activities across the construction value chain have a massive impact on environment, and innovation in design and materials is key to combating the climate destruction happening through this sector. We are privileged to have an excellent panel today with a rich experience in the building sector's decarbonization strategies at a national and international level. Throughout this session, we will benefit from them on a broad area of topics, including innovation in design and materials, international best practices, and their relevance to India. Before we get started, a little housekeeping announcement I would like to make. Before we get started, a little housekeeping announcement I would like to make. We have kept all the participants on mute to avoid any background noises. If you have any questions during the presentation, please type them into the Q&A box in your GoToWebinar control panel, along with the name of the speaker to whom you are directing the question. I will bring them up towards the end of the session. This session is being recorded, and the recording will be shared with all the participants. Before we move ahead, I request you to respond to a poll question which will be shared with you on your screen within seconds. You have 15 seconds to respond to this poll question. I hope all of you can see the results of the poll on your screen. So maximum vote we have got for the third option, which was recycle and reuse the building materials used. So thank you for sharing with us your response. Without further ado, I would first like to invite Dr. Satish Kumar for setting the context of today's webinar. Dr. Satish serves as the President and Executive Director of IEEE. He has a vast experience in scientific research, leadership in the energy efficiency space in multiple organizations like LBNL, USAID, Schneider Electric, and now IEEE. I request Dr. Satish to give the opening remarks and set the floor for the fellow panelists. Within seconds, I will just share. Just give me a few seconds. I hope all of you can see the presentation deck on your screen. So I would request Satish sir now to go ahead with his presentation. Over to you, sir.
Thank you, Shravani. And on behalf of IEEE, Let me extend a very warm welcome to my fellow panelists and also to all the participants who have joined us for this very important webinar. As you know, the topic for this webinar is decarbonizing building construction in India. And this topic, of course, I think is not new to most of us, but why is it pertinent and what can be done about it is what we are going to be discussing over the next 14-15 minutes before I hand it over to my next panelist. Next slide. So what are we really talking about when we are talking about decarbonizing the building construction sector? So here is some context for the problem that we are facing. So we are in a situation where construction sector is one of the largest contributors to the greenhouse gas emissions that comes out at the national level. And if we look at India, about 12% of India's total greenhouse gas emissions is coming just from cement and steel sector, which together combines about 40% of the total emissions coming from the building sector, which is 30%. What we also see is that I think we just don't think how construction is going to happen without cement and steel. And although I think some of my fellow panelists are going to talk about some of the other alternative materials, either there is a massive green premium that is associated with them, or sometimes there are maybe misconceptions or misperceptions about the usability or the strength of some of those materials. And we also feel that the policies and R&D focus on some of these alternative materials is not commensurate with the problem that we are facing. So what can we do about it? I think some of the approaches that I think people and organizations around the world or governments are taking is that I think when we look at the 1.5 degrees Celsius target, they are saying that we cannot achieve this target without addressing how do we decarbonize the construction sector. In fact, Bill Gates in his new book has essentially highlighted this problem where he's saying that cement and steel has to be decarbonized, and just like we are decarbonizing the power generation sector. And as the poll question mentioned, I think there are different, strategies in terms of dematerialization, recycle, reuse, low carbon products. These are essential for, I think, this decarbonization that we are talking about. It will involve structural shifts and time spans of, I think, several decades. I think it's going to be very hard to do it earlier than that. And then you need a holistic approach involving policies, R&D, business, technologies. All of, I think, these segments need to come together to solve it. And what is the big prize we are talking about? So we are really talking about if we want to win this battle against climate change, we have to address this topic. This may sound very hard. It's a hard to abate sector, but it's something that has to be done. It will also lead to many co-benefits in terms of air, water, and land pollution. Land is pretty scarce in India, and I think I'm going to talk a little bit about that. And then the big prize is that hopefully we will go down a path which is going to be more sustainable, and it will lead to sustainable transformation of the construction industry. Next slide. So one thing that I want to quote here is that we all need to work together. There is a quote by Kenneth Blanchard, I think, which says that none of us is as smart as all of us. And I think one of the ideas that we are pursuing here, and I think that different speakers who are a part of the panel will bring their perspective, I think, onto this effect. And the other thing that I would like to say is that if we are not starting to address this problem, just like this pandemic has shown, that risk is, I think, what you don't see, what we are not talking about, and we are not prepared for. So I think this is not something that we don't know. We know that this is very hard, but something that has to be tackled, I think, on a war footing right now. So I think that is, I think, the problem, and I think we all would agree that the price is pretty big to take it upon, I think, in a massive manner. So next slide. So essentially, I think what we are looking, these are just, I think my presentation is going to set some context. So these are some numbers that I just want to share with our users, with our viewers. So if we look at the construction sector, I think the gross value added contribution from this sector is about 7%. It generates employment for more than 50 million people in India. So fairly large number of people's livelihood is dependent on this sector. So it cannot be that a problem that we come up with cannot starts to address, I think, some of these challenges at the same time, which are more socio-economic in nature. And when we talk about, I think, the economics associated with it, just the real estate portion, we know that, I think, infrastructure, I think, is where I think a lot of cement and steel is used. But just the real estate segment is, I think we are talking about 65,000 crores. So if I translate that in US dollars, I think it's about $8 billion, I think, is what the real estate market is. I think that is expected to be in 2040. And that is going to be like about 5 times bigger than what it is right now. If we look at the numbers in terms of the greenhouse gas emissions impact. So as I said that 30% of the emissions does come from the construction sector, from the building materials that is used, and 40% is coming from the steel and cement sector out of that 30%. So I think its impact on greenhouse gas emissions is significant. And why is cement and steel so critical? Because if you look at the emission intensity of per ton of cement that is produced, it's about 0.67 tons of carbon dioxide. And I think that's the reason I think it's considered a very, very energy intensive material. And its impact on embodied energy in terms of, I think, building construction is considered pretty significant. If you look at steel, it's even more, I think, energy intensive. So almost like 2.7 or 2.8 times as energy intensive as cement. And what makes, I think, these materials, I think, is so important to construct. I think whether we are talking high-rise buildings, whether we are talking bridges, whether we are talking roads, whether we are talking airports, I think cement and steel, we cannot visualize, I think, any construction without these two materials. But the bigger question is that, do we really need cement and steel for, I think, some of the housing construction, for some of the low-rise construction? And I think are people, practitioners, aware of it? Are there policies which encourage those materials use? And we are going to hear about, I think, some of the things from our speakers. And the last point on this slide is that the cement and steel industry, the reason it is considered so hard to abate is that the alternatives are available. There are some green premium products, I think, that are available. But I think because it is not at scale, availability is not at scale. So there is a huge green premium, I think, that is associated with these alternatives. And while I'm not an expert, I think, on some of these alternative materials, I think we will hear from Mr. Ramani about, I think, the availability of these materials. But I know that perception about these green alternatives is not that great. People feel that they are not as strong, or if I'm going for a very large project, then the supply chain is not fully developed, which will allow me to actually deploy these materials at scale. So I think these are some of the challenges that we are facing right now. Next slide, please. So I think in terms of what we also know that if you look at the raw materials that is being used to, say, produce cement, or if you look at the weight of these materials, these are fairly heavy materials. So it's not just that the energy intensity of these materials is a problem, but the transport of the raw material and the finished product also constitute a fairly significant proportion of the greenhouse gas emissions that come out of it. And it's not, I think that makes this even more challenging. The second part that I just want to quickly touch upon, because we are talking about construction sector, is that the construction and demolition waste that we are talking about is another very significant problem. And that's why I think the recycling of these products is so important. Right now, we are literally talking about 1% of recycling that happens. Whereas if you look at some of the other numbers, I think in terms of what US or UK does, I think it's much better, I think, in that sense. Um, as far as I think the percent, I'm not sure whether this China number is right, because my sense was that both, okay, I think the line graph is basically telling you what percentage of the construction material is recyclable. So you can see that China and India don't do very well when it comes to recycling of construction and demolition waste. It's just about 1%. Whereas I think if we look at US, UK, and I think in Netherlands, then I think they do much, much better than India. And I think on the left-hand side, you see the amount of construction and demolition waste that is coming out from China, US, UK, and India. And I think it is not just that the volume of these products are high. I think clearly for, I think recycling for landfill, it goes into land, and land is a very valuable commodity. Sometimes there are chemicals and hazardous substances that leach into the ground, I think making our aquifers and groundwater tables actually getting polluted. So that also is a pretty significant problem. And we cannot solve this problem unless we solve, I think, how we are going to recycle and reuse the construction and demolition waste. So that is another part of, I think, this issue that I just want to highlight. Next slide. So what has, I think, India done so far, I think, on some of these things? And I think if we look at two aspects of energy consumption, I think from construction industry perspective. So the first part is the embodied energy. And I'm sure that Professor Ashok Lal, I think, is going to talk about some of these things in his presentation. But most of the effort that we have put in place, if we look at the policy effort, or if we look at some of the R&D that is happening, a lot of it is focused on the operational energy consumption. So if we talk about building energy code, if we talk about standards and labeling, or in enhancing the efficiency of appliances, or even some of the later kind of initiatives like global cooling price and other things, most of these things are really clearly focused on reducing the operational energy efficiency. We really do not see, I think, what is happening once the building is getting constructed. And once the structure is ready, then I think we are just, I think we forget about, I think, what's the embodied energy that went into the construction of these structure. So I think that is a very, very important point that I would like to highlight. Same thing if we look at the PAT program. PAT program is another very, very, I think, ambitious program of Bureau of Energy Efficiency, and it is doing well. But I think if we think about, are we thinking about substitute materials for cement or steel, and what kind of, I think, innovation or what kind of policy push or R&D support is being provided, I think that we don't see, I think, becoming mainstream, I think, very, very soon. So that's the challenge that I think we face from, I think, the current actions on the policy, on the R&D front, and even on the technology front. And that's what I think we are talking about this slide. So wrapping up, I go to the last slide where I'm going to pose 3 questions for our panelists. And I know that different people are going to be addressing these questions. So maybe I think the first question, where maybe Tim is going to be very well suited from his work at Arup, and Arup does a lot of work, I think, in the infrastructure space and on the sustainable front. So the question is that what is the best practice, I think, in terms of the international approach for low carbon transition in construction industry, and what could be relevant for India, and what should be the Indian future construction trajectory if we have to really start to grab this bull by the horn and start to take some, I think, concrete actions. The second question that is there is, what is the scope of design and construction innovation in this transition? Because we know that, I think, the sustainable energy transition, I think keeping the emissions at 1.5 degrees centigrade level, I think all these are very, very, I think, important questions for humanity right now. And what is the role of the design and construction industry, I think, in this? And how material demand can be optimized for future building constructions to reduce embodied carbon in the structure, in the infrastructure that we are designing. And the third and last question is, what role the low carbon or zero carbon alternative materials have in achieving the low carbon transition? How good are these materials? Are they ready for prime time? And what kind of policy or business support, I think, is required to make, I think, these materials mainstream? What is their current status and how to accelerate some of these efforts? So thank you very much, and I look forward to the discussions and to the presentations of my fellow panelists. Over to you, Shravani.
Thank you, sir, for your presentation. Oh, sorry, I was on mute. Next, I would like to invite Mr. Tim Chapman, who is the Director Infrastructure at Arup UK and has worked extensively to address the key challenge of decarbonizing the UK's infrastructure systems. He was awarded the ICE President's Medal in 2011 for his remarkable work in the infrastructure sector decarbonization. I now request Mr. Tim to share his experience on mitigation strategies for construction sector emissions and the relevance to India. Over to you, sir. I will share the control with you.
Thank you very much. Oops. And hopefully you can now see my screen.
Yes, sir. Perfect.
Excellent. Thank you, everybody, for the invitation to come. I'm really honored to be here and to talk a little bit about decarbonizing construction. The bits I'm probably less aware of are the context in India, so I'm here to present more of the international perspective on things. And also, I should confess, I'm an infrastructure designer more than a building designer, so I'm just sort of highlighting that particular point as well. But I'm going to talk a bit about what's happening globally and what's happening in the UK in terms of decarbonizing actually the whole economy, because we in the built environment sector have got the power to change everything if we really try and do that properly. So my key points I'm going to make in this project, in this quick presentation, are decarbonization can only be done strategically. We need to change big national systems, and people's expectations need to change, and they need to partake and facilitate these changes happening. To do that, we need wise political leaders to lead, and they need to be well informed. And that's, again, I think, part of why we're here today, to try and make sure that we can come to a consensus about what should be done. So in terms of the UK, this is a very quick chart from 2016 that shows the critical, that shows the critical elements of the UK economy in terms of the carbon emissions. These show that the infrastructure sector, so what happens in power generation, transport and waste management, are about 55% of UK total territorial emissions. And buildings, the sort of businesses, factories, offices and residential, about another 31%. So overall, we affect about 86% of UK greenhouse gas emissions. And the fundamental things we need to change here are how to decarbonize electricity, and UK has done a huge amount of that over about the last decade. Very, very big changes to the grid, lots of renewables, no nuclear, I'm putting biomass in question marks there because we also have some biomass, and I'm a bit dubious about whether that should count as low carbon, or actually I'm very skeptical about whether that should count as low carbon. But I mean, these very big changes are made, costing an awful lot of money, but it's actually done an awful lot to decarbonize the UK. We need to electrify transport, rail, cars and vans, lorries, shipping and air. And this, we're doing some progress on this, but actually not nearly enough. And we need to decarbonize heating, and I recognize in India cooling is a bigger issue for you, and there's lots of work to be done on that as well. So we've just started on a voyage of how we can actually decarbonize a major economy. We've made good progress, but so far we've only really done the easy bits, and the more difficult bits are going to cost a lot of money and will end up also needing lots of societal change. I'm just going to touch on the topic of net zero. Overall, as a species on this planet, we emit about 40 or 50 billion tons of CO2 per year, largely in energy use, but also in some other areas as well. Doing this as on a species level, on a global level, is fairly easy how we decarbonize. We need to change the overall flux of CO2 going into the atmosphere. As a nation, it's also fairly clear because our boundaries are fairly closed. There's some difference between the territorial emissions, what we actually burn in our particular country, and what we actually import and export, our consumption-based emissions. But overall, we can actually do these sums fairly clearly as well. But in the UK, an awful lot of city regions and companies are declaring net zero, and it's actually quite difficult to know what they mean by this. And if they're just going to do it by offsetting, it might actually not be the right answer for us overall. So I love the concept of net zero. We need to try and achieve it, but I'm a little bit worried that a lot of people are declaring it but might not really be doing it, and this might be not so good for us all. And also just thinking about the society we wish to create. So we're going to change how our whole economy works. We're going to actually sort of change all of our power, all of our transport systems. We need to have a vision for a future that we all want to partake in. So we have, as an example, the slide on the left, the picture on the left shows a whole lot of connected autonomous vehicles. And if we just, all we do is just actually make sure that they are electrified and therefore the tailpipe emissions are reduced and maybe autonomous and connected in some clever way, actually we haven't changed the world at all. We still got lots of congestion and all the externalities of car use. So we're not necessarily creating a really good future. On the right shows a very simple sign from downtown New York where a very simple parking lot was changed how the whole neighborhood went. And during it, shops did much better business, people had a much nicer way of living. So some very small urban changes can have a very big effect. And we need to be very alive to these sort of things. This slide I'm sure you're all very aware of. The left-hand graph shows the overall global emissions climbing up to sort of 40 billion tons of CO2. And on the right-hand slide, it shows what's actually happening from each of the countries. So as you can see on this graph, many countries are doing something, but the really big increase here is China, which went from about 2 or 3 billion emissions, tons of emissions in the 1970s, up to about 12, so about a 10,000 million ton increase in CO2 emissions. The Indian graph is in orange. I've actually just extrapolated the Chinese graph forward. So if India develops like China did, with the same sort of heavy use of steel and concrete as Dr. Satish talked about, the world is going to actually suffer hugely. All the decarbonizations of the rest of the world might just be used up by India emulating China, and this wouldn't be a good thing. I think India has got a huge opportunity to decarbonize in a very wise way. So absolutely, every Indian deserves the right to be middle class. We need to allow India as a globe to actually to develop, but we also need India to do that in a wiser way than the West has done and that China has done before it. And very quickly, I mean, were China to actually go on this very high trajectory to be emitting 10 or 12 gigatons of CO2 per year, then actually India would then have a huge effort to try and actually reduce that afterwards. The right-hand graph shows what China has done, the huge increase in its emissions, and now the necessity to get them down in a very quick way, which is going to have to change its whole economy. So the critical issue here is trying to learn from what the EU are doing and what the UK are doing. The UK has done, as I said before, has done all the easy things so far. So the UK emits about a gigaton about 10 years ago, 20 years ago, But by stopping coal generation, lots more renewables, but also actually offshoring manufacturing, which doesn't help the globe at all, the UK has made some really big strides. And the EU has now made the same commitment and is showing sort of a similar trajectory, both trying to reach zero emissions by 2050. So there's a lot to be done. To help do that, I'd just like to introduce very quickly a standard called PAS 2080-2016. It's been updated at the moment and it's likely to become an ISO, so therefore it will be basically one of UK's gifts to the world. We worked out in a very complicated way how we could decarbonise construction and especially infrastructure. And so this is the world's first standard for managing whole life carbon in infrastructure systems. And as part of the chance to update it, it's going to be extended to buildings as well. And very simplistically, what it tries to do is create the correct big picture view on everything. And by looking at everything on a national basis, it gets rid of perverse incentives. And very simply, it defines low carbon as the capital carbon, which is also known as embodied carbon, the operational carbon, and the use carbon. So giving an example of a major airport, it just shows sort of capital carbon is actually building the terminals and the runways. Operational carbon is actually how the airport is run. So obviously the lighting in the airport, the ground staff who actually maintain the airport. And then use carbon are all the people who come along and bring it and fly planes and actually land them and the carbon they emit. Currently, these are excluded from international debate about carbon emissions. They're excluded from national figures and they're left in their own box, and therefore nobody really owns them. But increasingly they're being actually owned, and Britain is now taking measures to actually own its use carbon figures of what we emit globally. And from the airport operator point of view, they can control the first two, but they can only really influence the airplanes that fly into the airport and things like that. So the critical thing here is PAS 2080 allows us to invest to save and optimize to reduce. So it uses the same sort of terminology in terms of CapEx and OpEx, which we use for money, and therefore I think it makes it very easy to relate to. And again, I'm not going to go through the figures on this in great detail, but it shows actually what happens in the UK emissions in each of the infrastructure sectors. So the really big ones are energy and transport, as my earlier slide showed. So we use about 200 megatons of CO2 per year in energy and about almost 200 for transport. And these are largely used in terms of how we use the energy, but also a little bit in the operational side and not so much on the capital side. But as we actually make our systems more efficient, the capital side will become more important. But the UK is a very major developed economy. We've created our infrastructure over the last 2 centuries, so we already have a very mature set of infrastructure. In India, like China before you, you're about to spend a huge amount of money and a huge amount of carbon on how you create your future infrastructure. So we need to make sure that India watches the capital carbon very carefully, but also creates the right capital carbon to make sure that the operational and use carbon are reduced as well. There's no point, as an example, building a new road that only can take gas guzzling cars on it and hugely emitting heavy goods vehicles. We need to make sure that India creates a transport network that's also easy to use in a low carbon way. So how should we pick the right projects to build? We need to make sure there's a clear investment case. And in the UK, this is called the Treasury's Green Book, which actually goes through how government should appraise schemes. And traditionally, this is actually really focused on the benefit to cost ratio because money talks. And the Treasury is worried about actually spending money and getting good value for it. And this will still persist in the new world because money remains scarce. But actually, carbon is scarce as well. And therefore, we need to talk in the same way about BCR, we need to talk about value for carbon and making sure that every project we do is a step towards a low carbon future. It also should enhance society, make sure we worry about societal capital and enhancing nature as well. And so in those projects, we obviously need to reduce the capital embodied carbon. And so the picture on the right shows what happens to a cubic meter of concrete and where the current emissions come from. And a large part of it comes from the cement, the steel, but also the construction process, the transport, the admixtures, the aggregate, and the batching processes. So going back to Shawani's question at the very beginning, in terms of how you answered this, you have some of the answer on this slide. So in the UK, with our processes for making steel and concrete, it's about 430 kilograms of CO2 per meter cubed of concrete, of which 60%-ish is cement, which we're going to hear about very shortly. But also we need to make sure that as we do the projects, we satisfy the client's sought outcome and we don't compromise whole life carbon. And I'll give an example, a new rail project. I'm seeing people at the moment where we're building examples like High Speed 2 in the UK, a very major new high-speed railway line. People are trying to make the capital carbon smaller, but actually the critical thing is the stations we build are attractive to users. We stop people using their cars instead. So the critical thing we need to do is make sure we solve the total carbon problem and not just the capital carbon. And we have the hierarchy of doing things, of building nothing, building less, building clever, and building efficiently. And sometimes the best thing to do is to build nothing and to use technology or something else as the right solution. And then we can work our way down this sort of hierarchy and ultimately just build where we have to build something, build it efficiently instead. So for India, again, just picking up and echoing what Dr. Satish said, we need to mitigate for 1.5 degree warming of the world. It's absolutely critical that we follow this. And India's got the chance to avoid the mistakes that we've made in the developed world. So develop. Every Indian has the right to become fully middle class like we are here in the West, but do it in your own better way. Go straight for the right answer. Don't make the same mistakes that we have made. So invest in public transport, but make your cities livable at the same time. Invest in electrified rail, make freight transshipment simple. Use solar and other renewables. We all need to find better batteries. Ban coal quickly and invest in nuclear. With lots of hydrogen and carbon capture and storage and everything else, and ultimately direct air capture to make sure we capture the errant emissions. Choose the right buildings, make them flexible and capable of repurposing, so you don't need to keep on rebuilding them like we have done here, and make the circular economy work. But in parallel, we all need to adapt for a 4 degree warming as well, because I must admit I'm skeptical about whether we can do enough quickly enough to make the changes. So we need to mitigate and we need to adapt. So that's the end of my talk. Thank you very much for your attention.
Thank you, team, for this wonderful presentation. Moving forward, I would like to call our next presenter, Mr. Ashok Lal. Architect Ashok Lal, who is the principal at Ashok Bilal Architectures and specializes in environmentally and socially sustainable design, and is practicing architecture in Delhi since 1981. I now request Architect Ashok to share his experience of low carbon design approaches and innovations in construction, leading to mitigating carbon emissions. Give me a few seconds, sir. I will share the presentation. Over to you, sir.
So you are self-muted.
Sir, you are self-muted. Ashokji, you are self-muted. Please unmute yourself.
Right.
Yes.
Now you can hear me?
Yeah, perfect.
Oh, great. Thank you very much, Ravani. So I think we can move on to the next slide straight away. I think this is just a kind of a review of the overview on buildings that Tim was also showing us, just to say that we are in this particular talk talking about the embodied energy in building construction, particularly the materials part of it, the production of materials and the use of materials in the buildings. I'm ignoring at the moment the transportation and the lifetime and the recycling potential of it, etc. Just looking at only the materials that are consumed in the making of the building and the cost, the embodied energy cost, so to speak, of the making of those materials. Next. Can we go to the previous slide? You've jumped one. I've lost the slides. Yeah. Well, this is an important slide because what it says is the black line is the indication of embodied energy, which is something which, the theory of life cycle costing said that you can amortize the embodied energy over the life of the building, which can be 60, 70, 80 years. And then this was at a time when the operational energy of buildings was quite high, especially in the West. And that is the red line that is going steeply up. And then, as you can see, as you improve the performance of the buildings in operational terms, that inclination then begins to come down. And then eventually, as you really get very efficient buildings, almost net zero emissions in operation, you get a very much flatter line. But what it does show is that embodied energy becomes a more important component of the overall contribution of carbon dioxide emissions. It becomes a very important component. And what I really do want to point out is that if we say that we have a window of opportunity of not more than 1 or 2 decades, within which we have to reduce the carbon footprint of buildings, then, especially in India, when we are going to multiply the amount of building that we need for a growing population in the process of urbanization, we have to pay a lot of attention to embodied energy. That is actually the greater job than the operational energy, especially of housing stock. Next. Well, in buildings, this diagram is a very simple one, but what it shows is that something like 65 to 70% of what a building is made out of is at the embodied energy of 65 to 70% of the embodied energy is attributable to what we call the structural system and the external envelope of the building. So this is where the bulk of the embodied energy is located. When you have high, very intensively service buildings and they have a lot of air conditioning and piping and servicing and so on, that also, because of the extensive use of metal, that also becomes quite a significant consumption. But in our case in India, most of the buildings that we are going to be building are going to be relatively simple in terms of their services that they incorporate, relatively simple. And so actually 70 to 80% of the embodied energy of construction is attributable to the structural system and the building envelope itself. Next. Next. Well, this is a project that we did several years ago, and we did an analysis of it. And what this analysis shows is that, as Tim said, and as Satish said, steel is a big culprit here. Steel and concrete and reinforced concrete are the big culprits. So you'll find that by mass, steel is not more than 2 to 3% of the total mass of building. In cost, it's significantly higher. And in embodied energy, it takes the cake. So here's a good pointer. If you're going to have a strategy about controlling carbon emissions in building, watch out for steel, watch out for concrete. Next. The other thing to look out for is that we should look at, 3 kinds of buildings. I'm talking about residential buildings here. So we have lots and lots of buildings which are now becoming 2, 3, 4 stories high as cities become more dense and land becomes a little bit more scarce and people want to live closer together, 3, 4 stories high. But in some cities, they say, no, you must build taller. They go 7, 8 stories high. And in some cities, they say, no, you can go as tall as you like and you build 10, 12, 15, 20 stories high. So you've got these 3 kinds of buildings that are coming up. And there's a shift. Somehow the belief has gone around that you have to go vertical. You have to go vertical. You have to be like Singapore. You have to be like Hong Kong. You have to be like New York. That is modern. That's the way to the future. Something is wrong in that calculation. And we will see now why. If you just compare the sizes or heights of building. Next. Well, what we see is that as we build taller, we consume more steel and cement because the building needs to have a stronger structure. It has to resist earthquakes, it has to resist gravity and wind loads. And so the consumption of steel and cement, and therefore the embodied energy per square meter of built space delivered, increases by 10 to 15% as you go from 4 or 5 stories to 6 8 stories, and even further as you go taller. So here's something to think about. It's not only about substitution of materials, it's not only about economical design for whatever you have to build, but it is also about making choices about the kinds of building that we need to build in order to conserve energy, embodied energy. And also there is a potential of substituting some of the walling materials, the infill materials from, there's a movement towards all reinforced concrete walls inside, outside, everywhere. They think that's the right thing to do, but it's going completely in the opposite direction from trying to reduce embodied carbon construction. It is actually accelerating the increase in carbon emissions due to construction, if we go that way. Next. When you click more, something will come. Next. Yeah, so I just want to show those 2 slides just to say that as you go taller, your operational energy also goes up. And as Tim was saying, not only do you want to conserve energy at the time of construction, you want to conserve carbon at the time of construction, but you also want to build in such a way that later on you don't have to pay a price for it. So again, building taller has that difficulty. One interesting thing for India, particularly if you're talking about net zero possibilities for the future, is that the ratio between the rooftop available for converting sunlight into electricity, if you're going 4, 5, 6 stories high, is favorable for you. You can find almost 80% of your annual energy needs for simple living in homes if you build 4, 5 stories high. As you go taller, that ratio deteriorates. And so there's another reason, looking at total systems approach towards net zero. Next. Also, it so happens that steel and concrete are really the more expensive part of the building in any case. So if you save there, you make buildings more affordable. So it's really about choosing the type of building and also choosing how you build the structure and the envelope. Next. Well, this is just an example of a building that was built about 10 years ago, 15 years ago. Development alternatives. Next. We'll talk about it a bit. Here, what was done was that the horizontal spans were either ferrocement shells or shallow domes. And the ferrocement shells significantly reduced the amount of steel consumed in spanning the space. And the shallow domes eliminated this steel. And there was no steel, no concrete. It was just a masonry dome, but it was shallow. So this was an innovation, not very scalable, but it was a demonstration of how ingenuity and design can still, for modern buildings too, work with less steel consumption. Next. Here's a picture of it. Next. And on the right-hand side, you see the shallow domes. On the left, you can see a substitution of the external walling material. Here, the old earth building, in place of which the new building was built, was pulverized and was converted into cement stabilized blocks in combination with an inner lining. I mean, there was an inner lining of earth blocks and an outer lining of fly ash blocks. So very low embodied energy in the external envelope of the building. It's a substitution of what might have been traditional brick or concrete. Next. And this is, you have to think about the detailing and the use of timber for doors and windows. Well detailed, well seasoned timber instead of aluminium. And actually you get very high performance windows at the same price as the modern aluminium windows, but at 1/20th, 1/30th of the embodied energy cost of providing windows. Next. And here's the alternative materials that were used for walling. There are many options that are still available, and people are moving in that direction gradually. But still, it's not quite scalable. That's the issue. I think it's a question of getting, if there's better demand and the quality, because this is not always formal industry, and the quality can be assured, scalability will arrive. Next. And this just to show that whether it is in the structural system, whether it is in the infill system, and whether it is in the doors and windows or other subcomponents, in each of these departments, there can be a strategy of reducing embodied carbon significantly. Next. About construction systems, a couple of innovations that are on the anvil now and they're just about taking on. Here's a block. It is a concrete block. It can be made very simply by on-site casting, and there can be a mechanized method of producing it, also a plant on-site. This is an interlocking block. As you can see, it has got holes in between. Next. You can lay it as masonry. Next. Very quick because it interlocks and you don't need any mortar in between. And in the annular spaces, you pour the mortar, and you can occasionally also have reinforcing bars with concrete around them. Now, this is the principle of contained or constrained masonry, where the constraining of the masonry by introduction of the bars with a bit of concrete takes care of the lateral loads of earthquakes and wind, and the block itself, the masonry itself, becomes a load-bearing system. This is very good up to about 4 stories high, quick to build, very economical, and reduces steel intensity in the construction by a good 15 to 20% compared to an RCC frame. Next. This has now been tried and tested and designed, and it is waiting for formal approval from the Building Materials Trade Technology Promotion Council. Next. Here it is. Here's the system. Very appropriate for affordable housing, up to 4 stories high, small buildings, not large spans, very little steel consumed. We'll talk about the quantity in a little while. Next. And this is how the system has been actually tested for its structural stability in Bangalore at a technology institute, and now been certified. Next. And it has now been proposed for a housing scheme in Tamil Nadu. 600 homes are to be built using this technology. It was great that the client was willing to understand it and move with this innovation. We really do need some clients like that, and we certainly need the state to look for such innovations. We'll talk about those innovations later in our discussion. Next. Here's another thing. There's a factory now established in Calcutta that's going to produce these lightweight hollow clay blocks. Same principle, but using clay instead of concrete. Next. You have these annular spaces which you can reinforce. This has the added advantage of lighter weight, but fairly good strength. Again, you can build up to 4 or 5 stories without any difficulty. And also insulation. So it's very good for external walling if you want to reduce the heat flux across from the outside to the inside. And this is, of course, developed in Europe as a system. A new factory has been put up in Calcutta that is developed, making these blocks. Something similar had already been established in Kerala earlier, but this has not been scaling, and it really needs to be promoted. The only difficulty in this technology is that actually it is rather a high investment industrial production system, because these blocks are extruded by a pressure extrusion using very good quality and well controlled clay. Very different from the concrete block that I was talking about earlier. That's almost like a cottage industry. You can produce it as a cottage or a small scale industry, whereas this one becomes a bit of a capital intensive industry. Next. And you have similar solutions for horizontal spans, where in the structural design you increase the depth of the slab, reduce the steel reinforcement, use filler blocks to reduce the weight of concrete, and thereby overall reduce the carbon emissions of the constructional system. Instead of these clay filler blocks, you can use lightweight concrete blocks also. Next. And this system also has now been, from a theoretical point of view, practically is being tested using clay blocks for seismic loads. Next.
Sorry to interrupt you, sir. You have 1 minute to wind up your presentation as we are running.
Yeah, I'm just about finished. Yeah, we move on quickly.
Yeah.
Yeah, this tells you about the thermal properties of this particular product. As you know, this is very much better from that point of view compared to the solid concrete block. And again, it answers Tim's point about built with low carbon to begin with and reduce the carbon emissions in operations. Next. Here's my proposal for policy. Have a carbon tax on construction, focus on steel. If you're consuming less than 25 kilograms per square meter of your built area of steel, then you can claim 5% back on your property tax. But if you are spending more than 35 kilograms per square meter of your built area on steel, then you should pay an additional 5% property tax. This is a rhetorical proposition, but this is really the crux of the issue. How to make designers, builders, have an incentive in going in the right direction. It just means intelligent design. Next. And finally, if we are talking about solar cities and towns for the future towards net zero, you have to talk to the town planning people. You have to have low-rise, high-density as the predominant form of construction, because that will be low carbon to construct now, that will be more affordable now, that will be low carbon for the future in its operation through its lifetime also. That's a strong recommendation. What we are seeing, on the other hand, in policy is a run in totally the opposite direction, which must be halted. Thank you.
Thank you, sir, for your presentation. Moving ahead, I would like to call Dr. R.V. Ramani, who is the CEO of Argus Concrete Solutions and specializes in zero concrete cement. He has delivered several talks and published more than 40 papers in the area of geopolymer concrete. I now request Dr. Ramani to give a presentation on low carbon cement for construction. Over to you, sir. I will just share with you the control.
Good afternoon, everyone, and thanks AEEE for the opportunity. So, we are now going to address a new area of decarbonizing the construction. So, as a lead auditor, I always advocate these 8 points to all our clients. That is, when you plan your project, when you start your design, so that's what I mean by start early. Before starting the project itself, you start working on your carbon footprint. And of course, heating, ventilation, air conditioning is a very big thing to be addressed. And I always advocate a continuous working with no stoppages, and then whether it may be construction, may it be foundation, may it be insulation. So this is one area where I think we can reduce a fair amount of carbon footprint. Lighting is another area. And how much of recycled material that we can use is very important. And we see in the team's presentation, it accounts for almost 1/3 of the whole carbon footprint. Water usage is very important. And of course, what is the amount of renewable energy that we can build into the project is equally important to us now. And of course, location of the project does add a lot of things, including local materials, logistics, and other things. The global warming, as you all know, is man-made, right? A lot of human activity has added to concentration of greenhouse gases. So a lot of natural resources have been extracted for using construction and building materials, and they consume energy, and there is a degradation of environment, and that contribute to the global warming. Buildings, as you all know, the other speakers also concurred, are the largest energy consumers and greenhouse emitters. So we need to address this more precisely. So let us see what the construction area can do to mitigate this. The first thing is that they use materials which are more efficient. The next thing is you use the existing buildings better so that you can cut down on demolition. You can switch over to lower emission materials and you use lower carbon cement. That's what we're going to talk now. And then you can recycle building materials and components. And you use very low emission construction equipments. And these are the areas. Now, I'm going to talk about low carbon cement, which addresses all of the first 5. The report from Sweden says that we have to cut down 26% of the usage of concrete and use alternate building materials by 2030 to maintain decarbonization standards. So which means that there's a larger emphasis on procurement and life cycle assessment and design of the buildings. 35% and 56% are the we need to reduce in steel and cement. So this is the report, C40 report from Sweden. And if you're able to occupy all the built-up area, the existing buildings, there is a 20% reduction in the need for new buildings. If all these things are addressed, They say about $11 billion will be saved in New York and in London. So let me tell you something about the low carbon cement. I call the lowest carbon cement. It's a geopolymer cement, and the concrete is called geopolymer concrete. It's quite new to the market, and I'll give you a small comparison with the ordinary Portland cement. And we tell you about what is the energy emission in this and what is the scope for utilizing the waste. It's a very important aspect, and the policy changes certain directions and some demo projects that have been done, and what are the technical barriers and challenges that we need to address. So when we talk about a new product, a new cement, let us first address that: is it cost effective? Is it quick setting? Is it user friendly? Is it eco-safe? Is it recyclable? Does it use less capital? Does it reduce water consumption? Does it increase more strength to the concrete? Or are we using more local materials? Maybe all of them are part of them that we should address. Generally, we can consider an alternative material. So the material that we are going to consider now addresses most of them. We are going to talk about geopolymers. This is the new way of making buildings. They are alkali-based cements. They use natural resources and the waste streams from the industry. There is no water required, and we don't need ordinary Portland cement and no additives to make this concrete. And it is 100% recyclable. Let us see what is the green quotient on this geopolymers. We can say what I'm equating to a 1 million ton of a cement factory, and the construction proportion to that. We can save about 24 million tons of reduction in CO2 and 60 million tons of saving in water, and about 4 million tons of waste can be used, and about 200,000 acres of land saved as landfill and mining. And of course, the fight and heat resistant properties does add to the benefit of this concrete. So I'll give you a small chart giving what is the saving over the normal concrete. You use a geopolymer concrete, you could save, this is per cubic meter, you save about 150 liters of water in curing only. At about 380 kilogram per cubic meter, we can use industrial waste. At about 0.7 square meter of land can be reclaimed back, and it can meet to all the CSR and T norms. These are all tangible benefits, and there are some intangible benefits, which is that we save about 300 kg minimum of carbon dioxide emission per cubic meter, or about 25% reduction in labor in construction, and 8 cubic feet of landfill reduction in mining and filling, and it is a totally sustainable green concrete. So let's see what type of an industrial waste or the mineral waste that can be utilized in this concrete. We can use red mud from the aluminum industry. We can use ash, rice ash, or the wood ash, or the fly ash from the different industries, and the steel slag from the steel industry, from maybe the direct reduction, whatever may be the furnace, we can use that steel slag. And the demolition waste can be totally used in this construction. And of course, copper slag to a large extent. The numbers that are given at the bottom is the amount in millions of tons generated every year in India. So this is a very big number, and if you utilize all these waste material, you can make about 70,000 crores of concrete in rupees. So the changes or what needs to be addressed in the policy by the government in using this new low carbon cement is they should make the waste streams usage as mandatory by all the people who are generating waste. and the waste producers should share a disposal cost. It should be a part of their project that they should share, and it is their responsibility. And there must be a mandate on this. And of course, contribute to the development of technology and testing. This is what is very important for new technologies. There must be a contribution from the industry which produces waste streams. And the CSR funds has to be used for waste utilization and restrict the landfill and mining. There should be another rule on this. This new technology can be used in government projects, defense projects, like Swachh Bharat, pothole filling, reclamation. So government should encourage such new technologies and collaborate for R&D and application development. So the waste stream people or the government should collaborate with the people who are already owning or developing technologies in making further R&D. This is the product best suited in using this geopolymer concrete is the coastal armor, and then the waste containment from different type of heavy metals and other things. And we can make instant container home for disaster homes, otherwise we call it. And there is an application called shotcreting where it can be very nicely used. And concrete roads, and then very extraordinary heavy foundations, and 3D printing of homes, and flame resistant concrete. These are very critical type of concrete that we can develop. You see in the photograph that the 3D printed home built by us using our material, and the flame resistant concrete used in a security zone in Switzerland. And the last one you can see shotcreting using remote shotcreting gun in a project in USA. So these are the other projects that probably I can share with you is the coastal armors that we have done to protect the coastal erosion and also the arrest the tide and waves. There are different type of constructions which can be used. And then the one photograph that you see here is a lining of the Mississippi River. And this is a coastal protection tetrapod done in Maldives. And this is a shotcreting of a tunnel. And we have done a number of tunnels using this material. And this is the one we can use containment of heavy metals and catalytic waste that's coming from petrochemical industries that are encapsulated in this type of construction. And of course, 3D printing, I told you in the earlier slide. We have about 8 varieties of cement composites to address all these type of construction possibilities. Right, in India, we have a very large coastline and we have a big budget on defense. And so there's a lot of scope in adopting this new technology in these areas. So just to name a few, we have about 7,500 kilometers of coastline which need to be protected due to 2 to 3 cyclones in the East Coast every year. And also we need to do some reclamation projects and where this material will come very handy. And we have about 30,000 kilometers of rural roads laid every year, and that can be done with this new technology. Emergency roads are laid by the defense in mountain areas to an extent of about 4,000 crores every year. And that takes a longer time, and you can save time, cost, and material, and also contribute to the carbon mitigation. Under the PMAG scheme, 62 lakh houses are to be built, which can be done very effectively. What I'm trying to tell is, you don't have to do everything. Just do 1% of the job initially. That will pave way for more jobs and then more saving of carbon. So I want to share you something, barriers on technical in using this material, which includes we need good R&D facilities. We have one in India and one in USA, but that's not sufficient. We need something much bigger, and it should be available to the public at large. Then we need a special standards. Of course, a new standard has already been formed and then it been circulated, but still that is not enough. We need more standards like the normal Portland cement concrete standards. The raw material logistics, because about 30% of the material being waste material, that logistics, there should be an arrangement. So that will improve the usage of waste material and reduce a reduction in cost. A lot of demonstration projects have to happen to showcase the product. And the training of technicians in other core area where this new technology need to be used by trained technicians, and public awareness on technicalities of the project and the usage has to be created.
Sorry to interrupt you, sir.
Yeah.
I request you to please finish your presentation in a minute.
Yeah, it is done.
Yeah, thank you.
See, I'm showing a video of a product. It's called the BioRock, made with geopolymer. It's made in our lab. So this is about 40-second running.
This is my geopolymer rock that has been in the water for about 18 months now, and the rest of the things around here aren't looking so well, but this really has a lot of shellfish growth.
Yeah, I come to the last slide. What you see is a type of an auditorium that we have planned using the waste materials and geopolymer concrete in the city of New Orleans to commemorate the 350 years of the city. It's called the Jazz Center. And the project is approved, and it will be it is crowd-funded and will be there in stream in the next 6 years. So thank you very much for the time allocated. Thank you very much. I hope I was on time.
Yes, sir. Thank you, sir, for your presentation. So here we end with our first session. I will now launch a poll question and request all the participants to share their response. I hope you are able to see the poll question on your screens. You have 15 seconds to share your response. So maximum response is for the first option, that is policy and regulations to limit the carbon in future construction. Thank you everyone for sharing your response. So moving ahead with our Q&A session, I have a question for Mr. Ashok Lal from Suyog Dharmadhikari. So Suyog says, what is the perspective on inclusion of recycled aggregate in mainstream construction projects, considering the engineering and financial challenges associated with recycled aggregate? Over to you, Ashok, sir. Sir, you are self-muted.
Yeah, can you please repeat your question? Thank you.
Yeah. What is your perspective on inclusion of recycled aggregate in mainstream construction projects, considering the engineering and financial challenges associated with recycled aggregate?
Well, recycled aggregate is obviously aggregate that is recovered or made out of demolition wastes, and it needs to be graded so that it is of appropriate form and strength to be included as aggregate in new concretes that have to be formed. For low strength concretes, there's a great chance. I mean, so if you're going anything up to, let us say, M10, M15 concretes for constructions which are not very tall and don't have to carry much loads and weights, I think the potential is high, but the standards and norms have to be established, and the material, appropriate recycled aggregate material, has to be developed and put into the market streams. Then I think there's a definite potential. But I do want to say something about the circular economy concept. In a place where we are urbanizing rapidly and where populations still continue to grow, where standards of living and conditions of life require more and more construction to happen rapidly, the circular economy is only going to take care of maybe 5 to 7% or possibly 10% of your total demands. The rest of it will still have to come from fresh resource. I haven't done my arithmetic on it, but that's my broad understanding.
Thank you, Ashok sir. So my next question is to Mr. T. So what has been the change after the PAS 2080 has come into force in UK? How the UK government is approaching decarbonization? Over to you, Mr. T.
Thank you very much, Sharwani. It's a very good question, and the UK government is only now embracing quite a lot of policies that fit decarbonisation, but also actually improving social value as well. So in the UK, we've had an issue with probably very uneven development around the country. A number of places have actually done very well out of globalisation, but some parts of the UK have done very badly. And the UK, as part of its obligations for COP26, are trying to work out how we can actually develop the country in a way that is much more inclusive. So they have published a number of documents to fit with the future. One very interesting one is called the Construction Playbook, that mandates how government should engage, and it's much more about whole life, much more about social value, and hugely more about decarbonisation and whole life decarbonisation. And PAS 2080 is part of that. Also, additionally, there are things that are happening across the whole sector. So government is one of the main actors, but actually all of the industry is as well. And I don't know how big Construction Declares has become in India, but the Construction Declares initiative in the UK, where companies, universities, clients are all coming up with a set of declarations of how we're going to come together to solve both the climate and the biodiversity crises. So there's quite a big uprising of awareness. Climate change is suddenly now coming to the fore. Clients are now buying much more climate aware solutions. Government is mandating them to, but like everybody at the start of something, a lot of the technology is not known, people aren't quite sure what's right, and therefore there's some misstepping as well, while people are trying to do the right thing but aren't always doing it. But I think there's been a sea change in terms of the attitudes over the last year or so, and I think this year is going to be even more so in the build up to COP26.
Okay, thank you so much, Mr. T. So my next question is to Dr. Ramani. What is the status of pilot project with geocement in the construction of buildings in India? What is the emission intensity from the geocements as compared to OPC? Over to you, Dr. Ramani.
Thank you for the question. It's a good question. I'll answer the second question first. Actually, the saving in emission will be about 70 to 78% by using geopolymer concrete. However, there are projects where we can save even more. It all depends on what type of a local waste material that is available. In fact, now we are handling a project in a country called New Caledonia, where we are not using sand, we are not using any aggregate stones. We are using completely waste materials only, where the carbon emission reduction is almost 88%. So this is the scope that is available depending on the type of project that we need to handle. The first thing is that you asked me about, is the status right for doing residential buildings? I think right now we are not in a position to compete with this cement lobby on the cement cost, because geopolymer costs are slightly expensive. So we used to find projects which can absorb this cost, and as well as where choose products where a normal Portland cement cannot address so efficiently. So that's why we have taken the coastline and other areas projects that I have shown you. And maybe to come into the building industry, it will come soon with the 3D printing around. Thank you.
So we have a question for Mr. Team from one of our participants, Isaac. He says, Team mentioned that we must prepare for a 4°C rise in temperature. This seems very alarming, and we don't even have LCA assessments in motion. How do we sensitize the population who will need to survive the 4°C peak? Over to you, Mr. Team.
Gosh, that's a very big question. And actually, again, I don't fully understand the Indian context for what we should do, because I'm not aware of the full effects of what it would be in India. But I mean, obviously, the effects are the same across the whole world. There's obviously sea level rise is a critical one, and we all have a lot of coastal cities. A second one, which again I probably worry about mainly actually for Asia, is the effects of the potentially lack of snow on the Hindu Kush. The great rivers of India and of China depend on annual snowfall. And when people are talking, when climate scientists are talking about the effects of extreme climate change, they talk about 3 poles, not 2 poles. So there's the North Pole and the South Pole, which got major issues, North Pole especially. The third pole they talked about is the top of the Himalayas and the effects on the great rivers. And again, obviously that would be catastrophic for India if the snow stopped melting every year. And then there's the actual more ordinary effects of climate change, different weather patterns, very, very changed wind, very changed rain, and the monsoon that hits southern Asia, including India every year, would be very different. So there's an awful lot to be done, and the timescale is actually long in our individual lives, but short in terms of, so it'll hit our children and grandchildren in a bad way. So the 4-degree rise is catastrophic, and we need to do everything to avoid it. But whether we can get to 3 degrees or 2.5 degrees, whatever the right answer is, or whatever the answer we get to, but everything we do to mitigate is important. But preparing people to do for the cataclysmic effects hopefully means that people will be happy to vote for politicians who spend more money to do the right thing.
Thank you so much, Mr. T. So my next question is for Architect Lal. So sir, you have mentioned about the use of timber for doors and windows, but what about using timber as a structural member in the buildings? Over to you.
Yeah, sure. Actually, there's a lot of work being done globally on the use of timber as a structural material for even tall buildings. And there are hybrid solutions in which you combine timber with concrete and certain amount of metal also, but significantly reducing the carbon footprint. It all depends on 2 major factors. One is the availability of the right kind of timber, so that it is harvested from sustainable forest resource. Second, an advanced timber technology. Unfortunately, about 15 years ago, when our forests were in a bad way, we banned the use of timber everywhere. Prices shot up, and we abandoned the knowledge of timber. Instead of saying, now this is the time to think of when the forests come back, that we should be able to use that resource as the only renewable building material resource that we will have. And it's a knowledge that we cannot lose. So all over the world, I mean, in the Scandinavian countries, in New Zealand, Canada, everywhere, there's so much work being done on timber. We really need to have collaborative systems where we can catch up on that technology and work with indigenous harvestable species in India. That has to happen. That's a big
Thank you so
policy
much.
shift, a big policy emphasis.
Thank you so much, Architect Lal. So here we end with our Q&A session. Thank you so much, all the panelists, for patiently responding to the questions. It was a great honor for having each one of you here today. Thank you everyone for being with us till now and helping us make this session an interactive one. The recording of the session will be shared with you all. I here end this webinar. Thank you all once again for joining us.
Thank you, IEEE.
Thank you. Thank you very much.
Yes, echo that. Thank
Do
you
I
very
have
much.
half a minute to make an important statement?
Yes, please go ahead, Professor Lal. Yes.
Yeah, it's like, you know, in the scramble for housing for all, the government of India has promoted what they call lighthouse projects.
Mm-hmm.
And it's ironical because lighthouse is supposed to be a little bit of light that tells you where the shore is, where you can be safe. But the lighthouse projects that we are getting into are multi-story, complete steel, concrete, high embodied energy, high operational energy, uncomfortable, unsociable housing systems that we are running towards. Someone has to say the right thing about it. That's all I want to say. Thank you.
Thank you,
Thank you
Professor
so
Lal. I think the idea definitely for organizing this, I think, topic and this webinar is to create awareness. We know that, I think, as Tim mentioned, he keeps talking about, I think, the politicians and I think the decision makers. And I think it's so critical, I think, in terms of how some of these decisions are being made. We keep hearing about cheaper, faster, and I think there is another term. I think whenever we talk about housing for all scheme. So the challenges are many. I think we probably, I think on this particular topic, Professor Lal, you are doing some amazing work. And I think we hope some of the policy suggestions and recommendations that are coming out, I think we can create some sort of a coalition or something which can go to the government and ask for, I think, some of these far-reaching decisions to be made, I think, in an appropriate manner. I mean, we know that these are challenging times. Government also has reasons for why it decides to do things. It's not that it's, but I would definitely say that we should probably have some sidebar discussions and other things in terms of where do we go from here. I mean, we want to work in this area, we want to create awareness, but how do we go about, I think, tackling this massive challenge? I think we will need everyone to come together.
Absolutely. I think it's very interesting how, like I say, watching India for the next decade is going to be fascinating, because I think you have the opportunity to show the world how it can be done, especially the rest of the developing world. And I think there's many people who will rely on you to do the right things.
Professor Lal, I have one question. I think some of the conversations that we have had, I think when we have said that why BMTPC or why I think IMAUA and other organizations are not specifying more sustainable way of, I think, designing some of these affordable housing units. And I think the point that is brought forward, that can we actually have the expertise, can we have the technology, and can we have the scale that can be deployed for us to hit our targets? And I think I am not entirely clear on this, whether this is something that we can answer. I think the other thing is that, do we need to build all this in such a hurry? I mean, that's another question that I think we can pose. But I mean, how do you respond to, I think, some of these rhetorical questions that get asked? They say that, hey, we will be very happy to do this, but I think we also need to hit our targets and other things. So can you actually help us do that?
Yeah, I think the answers are there. The biggest thing to realize is that about 60% of all residential construction that is going to happen in the next couple of decades will still be done by small groups and families individually and so on. So there'll be a lot of small time construction. 60% of residential units are going to be built in that manner, no matter what you do. The capacity for organizing land, companies, systems for delivering industrialized housing at that scale doesn't exist and will take a long time to develop in any case. So this will continue to happen. Of the 40%, only let's say about 10 to 15% would probably be done by the real estate. And the rest of it will be done by intermediary institutions, city development boards, housing boards, universities, hospitals, employers, and so on, and group housing societies. They would be doing that, medium-sized construction. And so if you recognize that as the way the terrain of housing provision actually lays itself out, then you need to devise material and equipment policies that enable each of these segments to move towards a lower carbon direction in construction. And the only thing that I can think of, which is the real bottleneck, is the way free market exploitation of real estate land by default produces the 20-story block. And that seems to be the model that's taking over all our big cities. All our tier 2 cities are still safe, and there's enough land to build simple homes in a more, let's say, diversified manner. And the kind of technologies that I was showing you are available, can be multiplied very rapidly, and they need more incentivizing and more support from formal systems of government. In fact, I mean, in Lucknow, they built 1,500 or 2,000 homes, 4 or 5 stories high, very sustainable, climate sensitive, good design, etc. Just this last year it was completed. So it's all doable, but somehow the vision that is being projected by the big leaders is just that kind of vision. They just need to see things a little differently. You're right, we need to have a consortium and have a platform for kind of round table, a comprehensive communication that makes sense. I think the answers are there.
No, great. I think definitely. I think we have to keep trying, and we have to continue to create awareness. And I think the work that you do, and I think some of the successful examples, I think need to be cited and quoted and shown, I think, to give the confidence. And I think there are enough sensible people that if they are approached, and I think we are also relentless in our efforts, I think we should be able to change this mindset that you are talking about. So, so thank you. I think we are past our I think allotted time. I still see more than 40 people on I think in attendance. So I would like to give a special thanks to those people. I think we will continue to work in this area. I think this is a pretty important topic. And we would request you to write to us, I think, with your ideas, with something. We are definitely looking for people to support this cause and to take, I think, some of the ideas that you heard voiced in today's webinar. So thank you very much. Shravani, anything else? Otherwise, we will wrap it up.
No, sir, that's it. So I
Okay,
thank you very
end this
much.
webinar. Thank you everyone for joining us today.
Thank you.